In today's lab, we're going to experiment with electric fields. And before we do that, we need to understand electric fields and electric potential, or voltage. So an electric field is defined as the force per unit charge that is exerted on any test charge, and an electric potential, or voltage, is the electric potential energy per unit charge. And these two are related to each other. The electric field can also be written as the difference in voltage between 2 points divided by the distance between those 2 points. When we draw an electric field, the field lines start on the positive charges and end on the negative charges. Then we also have equipotential lines, or equivoltage lines. And these are lines where the voltage is constant all along that line, and they run perpendicular to the electric field lines. For the setup, we have two arrangements of charged conductors. First, we have parallel conductors, and second, we have point conductors. But the setup and the procedure for both of these is almost the same, so even if you're only doing one of those setups, you should still watch all the way through the video because I'm not going to go into as much detail for the point conductors if I've already covered it in the parallel conductors. For both setups, we'll be using sheets of conductive paper with some conductive copper tape, and we'll put the tape on the paper to form our conductors, and then use a battery to supply the charge. So first we need to cut some lengths of our conductive tape, and you'll just measure these on the ruler, and then we'll cut them with a pair of scissors. So we need two pieces that are 12 centimeters long, so just measure that out, and then you can cut it with your scissors. Next, we need to create some tabs on our conductive tape. So do this by folding the tape in half, like this, lengthwise, and then you'll unfold it just a little bit so that you have about 1 centimeter at the end. This may be a little bit hard to see, so I'll just go ahead and do it and then show you what I mean. Okay, so you want to fold the tape like this. So I folded it first of all in half, like that, and then I folded it the other direction so that I have this tab in the center that sticks up about 1 centimeter. So it goes up 1 centimeter on one side and then down 1 centimeter on the other side. And we need to do that with both of them so that they're the same length. So again, I'm just going to fold this one in half, and then I'll unfold it a little bit so that it's got 1 centimeter, and then do the same thing on the other side. And I should probably also check just to make sure these are the same length now that I've folded them like this. And they look pretty close, so I think that will be good enough. Now let's grab a sheet of conductive paper, and I'm going to spread this out here. And it looks like it wants to curl a bit, so I think I'll grab some tape and just tack down the corners. Now we can attach the conductive tape to the conductive paper, and we're going to center them on this center horizontal line, and then they're going to be about 10 centimeters apart. So before, these strips were 12 centimeters long, but we have a 1 centimeter tab in the center now, and that shortens it to 10 centimeters long. So we're going to have one end of it here at 7, 5. So if you think of it as a coordinate axes, we have x and y. So we're going to have from 7, 5. That will be one end of it, and then the tab will be on the center line, and then the other end should be on 7, 15. The important thing, though, is to have the tab in the center. And then we'll have the same thing with the other one mirrored across the center of the page, so that will be on 21, 5 up to 21, 15. So when you go to remove the sticky backing from the conductive tape, you have to be really careful because it can stick to itself, or if it sticks to the paper too soon and you try to remove it, it's just going to damage the paper. It will rip up the finish. So be very careful when you place this. Get it right the first time, because if you don't, you may not get the second chance. So I'm just going to peel it up a little bit. I'm not going to take all of the backing off, just a little bit like this, and then we can place one end of it at 7, 5. So let me just line that up here at one end there. So I'm just going to tack that end down. I'm not going to stick the rest of it on for right now. Then if I stretch this across,
I can get that tab to line up centered on the center line like that. Then I can smooth this part out and then remove the rest of the backing from the conductive tape. Now the tab, you will want to stick it to itself, and I would recommend that you do that before you tack down the other end. So I'm just going to stick it to itself like that, and then I can stretch the other end across until it gets to 7,15. So I'll just smooth that out, and now we've got it lined up right along that 7 line, and the tab is right there on the center. Now I'm just going to do the same thing with the other. So again, I'll peel off the backing from the conductive tape, peel it back part way, and then I'm going to put this end now at 21.5. So I'll just tack the very end of it down, then peel up some more of the backing so that I can get to that center line. Very carefully, I'm going to line that up again, smooth it out, and I'm going to peel it up enough that I can get that center tab stuck to itself. And then I can peel it up the rest of the way and stretch that other end all the way down to 21.15 and smooth that down. And now I've got my second tab, so I've got both parallel conductors and then these tabs in the center. And these are going to be used for attaching alligator clips so that we can connect the battery to our conductors. Now it doesn't really matter which side you make negative and which side you make positive, that's up to you, it'll work the same either way. But I'm going to choose to do negative on the left side and positive on the right side, just like coordinate axes where you'd have negative on that side and positive on this side. So that's just a personal choice, you could do it the other way if you want to. Now just grab a 9-volt battery and the connector that goes with it, and then just snap that on. Now you notice we have 2 wires coming out of it. We have a red wire and a black wire. The red wire is positive and the black wire is negative. Then just grab 2 alligator clip wires. So these are wires that have an alligator clip on each end. So we can connect one end to our conductive tape tab and then the other end to the battery wire. So like I said, I'm going to do negative on the left side and positive on the right. And I don't have a red alligator clip wire, so I'm going to use white instead. So let me just connect that. So I've got the black, the negative here on the left side, and then I'll connect my white one to the right side, which will be positive. Then up here I'm going to connect the black alligator clip wire to the black wire from the battery, and just make sure that it's only touching the metal from the battery wire. If it's touching the insulation instead, then that won't be making a connection. The same thing then with the positive wire. I'm going to connect this white alligator clip to the red wire, and that is all set up now. Now I could just leave it like this, but it's kind of messy. We've got all the wires everywhere. So instead I'm just going to use some electrical tape and tack down these wires so that they're not moving during the experiment. And if you have time, I would recommend that you do the same. Next, we need to set up the multimeter. And the first step with this is to make sure you have the probes plugged into the correct ports. So we want black in COM and red in V for volts. The arrangement of these on your multimeter may be a little bit different. It depends on the model. So just make sure you pay attention to the labels, black in COM and red in V. Then we need to turn the mode dial to voltage and make sure that it's on DC voltage and not AC voltage. You'll see DC voltage is a line, a solid line with a dashed line underneath it. And then the AC voltage is a wavy line. So you don't want AC voltage, you want DC voltage. And we need to set it to the 20 volt range. So that measures anything from 0 up to 20 volts. Then for the probes, we're going to leave the red one disconnected for right now. And the black one we're going to connect to the same side as our negative conductor. And the reason for that is we're going to measure all of our voltages relative to this. So this will be our 0 volts, and then everything else will be relative to that. So just grab another alligator clip wire, and I'm going to use this green one for that. So just connect one end of it to your black probe. Then the other end of the wire we need to connect to our negative conductor. but there's not really a lot of room right here because we've already got an alligator clip connected there. So instead, I'm going to connect it to the other end of that alligator clip wire. Electrically, it's the same thing. So I'm just going to use this alligator clip and clip it onto the metal part of the black alligator clip. And again, this looks really messy, so I'm just going to rearrange things real quick and tape them all down with some electrical tape. The last part of the setup is to verify that we have done it correctly. So we're going to do that by measuring some voltages. Just use your red probe and first of all touch it to the negative conductor. And if it's set up correctly, it should read 0 volts, and it does, so that's good. Then we'll touch it to the positive conductor, and here we should get the battery voltage. So it looks like 9.3637 volts. That's about right, it's a 9-volt battery. And then if you put it in the center, so exactly in the center, we should get about half of that battery voltage. And we've got 4.7 volts, 4.69, something like that. That seems about right. It's about halfway between 0 and 9.3, whatever it was. So we've got this set up correctly, and now we can proceed with the experiment. What we're going to do now is start mapping out our equipotential lines, our equal voltage lines. And we're going to do that by just using our red probe and finding places where it equals 1 volt, or 2 volts, or 3 volts. So we're going to start with the 1 volt line. And when you do this on the paper, press it straight down into the paper. If you have it off at an angle, it may not register quite as accurately, so point it straight down into the paper. And you don't want to press it down so hard that you punch a hole in the paper, but just press it down hard enough that you make good contact with it, and it needs to be vertical, perpendicular to the paper. So I'm just going to put it right about here. I would expect 1 volt somewhere close to this. So we've got 0.99. Just shift it over a tiny little bit. And it doesn't have to be exactly 1 volt, but you should try to get it as close as you can. If it's a little bit off, like I'm just moving it imperceptibly right now, 0.99 here, I'm going to shift it over like half a millimeter, now it's 1.01. So anywhere right around there, that's where you want it. So I'm just going to make a mark right there. So I see that it is right there. I'm going to remove it. I can see the dent on the paper where I was pressing it. And then grab your yellow China marker and just put that right on top of that spot, and then just kind of give it a little twirl. Just twist it back and forth, and that leaves a mark on your paper. And it may not show up real well on the camera, but there is a little mark right there. So I'm just going to keep going like this. I'll just keep finding spots where it's 1 volt, and then I'll mark it with the China marker. Okay, so there's another spot, and I'll put it right there. This is a good time to mention, now that I've got everything set up and I've made some marks on the paper, I need to be very careful not to move the alligator clips that are connected to the conductive tape tabs. If I do, it could alter the electric field just a little bit. It wouldn't alter it a lot, but it would be enough that some of these marks that I've already left on the paper would no longer be accurate. They'd be in the wrong spot. So once you put marks on the paper, be very careful not to move the alligator clips. Just leave them where they are and just proceed with the experiment. Don't bump anything. That's another reason why the tape is good. It just makes it harder to accidentally bump things and change the position of them. Now as you're getting towards the ends of the conductor here, you should notice that the points, the line that they form, is curving out instead of just going straight, and that's what we would expect for 2 parallel conductors. They're going to be fairly straight in between the conductors, but the closer you get to the ends, they're going to start curving out. So just plot enough points that you can see that behavior. You don't have to go necessarily all the way to the edge of the page, but you could. I'm just going to maybe plot 1 more point on each end so I can see where that's going, and then we'll move on to the second line. Now that I've got all of these points mapped for this first line, the 1 volt line, I'm just going to use the China marker and mark a line that goes through all of those points. So I'm just sketch that. Doesn't have to be necessarily a curve. You could do straight lines between each one, but just kind of show that behavior. The equipotential line is going to go through all of those points. So this line was the 1 volt equipotential line. And I'm going to do another line for 2 volts, 3 volts, 4 volts, all the way up until I can't get any closer to this positive conductor. When you're first looking for these points, sometimes it can be difficult to predict where the next one is going to be, but you just got to keep trying it in different places until you find the voltage that you're looking for. And the more you do it, you will get faster at it. You'll be able to predict where the next point is going to be. Right now I'm mapping out my 8-volt line, and this will be the last one that I'm able to do. 9 volts would be too close to the conductor, so this will be the last line, and it should look fairly similar to the 1-volt line that we did at the beginning. Now that I have all of the equipotential lines, I need to go back and label them, label the voltage of each line. So I'm just going to go here and do +1 volt for that one, +2 for that one, +3, +4, +5, +6, +7, and +8 volts. Now we need to add the electric field lines, and for that we're going to use the red China marker. Now, mine has already worn down a lot. It doesn't have much left to write with, so this is a good example to show you how to sharpen it, so to speak. It's not exactly sharpening it, but it's sort of the same effect. So you'll see it has like this little string, and if you pull it down just a little bit, you can kind of use that to get a start on this paper, and then you literally just peel back some of this paper, and you peel it back all the way around until you have exposed more of the lead up at the top. Now I've got it peeled back and a lot more of it is exposed, so that should work well now for writing. I do need to be careful though, with it longer like this it is more likely to break off, and so you just have to watch for that. Now, like I said at the beginning, equipotential lines and electric field lines are perpendicular to each other. So in order to draw the electric field lines, we just have to start at one conductor and draw across to the other conductor, and whenever we cross an equipotential line, we just have to cross it at 90 degrees perpendicularly to it. So I'm just going to start here on my negative conductor right in the middle. We know that one's going to be fairly straight, so I'll just draw straight across to the positive conductor, and we'll just do several lines like that. Try to draw them so that you're crossing the lines perpendicular, and when you get out here to the edges, that one's going to be a little bit more tricky, but you just kind of have to. Okay, so this is what I was talking about. The lead is long and it just broke off, so I could resharpen it, but I think I'm just going to use this little nub of it and continue drawing my line. There we go. So as I was saying, just keep going like this. Whenever you cross the line, do it perpendicularly and start on one conductor and then get back to the other conductor. This is not very easy to draw with this little thing, so I'm going to have to stop and sharpen it again. Now I need to draw arrows on the electric field lines indicating their direction. So we already said that electric field lines originate on positive conductors and end on negative conductors. So this one on the right is my positive conductor, and the one on the left is my negative conductor. So I just need to draw arrows that indicate the direction from positive towards negative. And that's it for drawing the electric field lines. Now there's one more thing we need to do. I'm going to use a ruler for this, and we need to measure the electric field strength between the conductors. So we already said that electric field strength is equal to the difference in voltage between 2 points divided by the distance between those 2 points. So if we use our equal potential lines as our voltage points and then measure the distance between them, then we can divide the voltage difference by the distance and get our electric field strength. So you can choose any 2 lines that you want close to the center. So in my case, I might choose any of the lines that are evenly spaced, so maybe 3, 4, 5, 6, and 7, or maybe just stick to 4, 5, and 6. I think I'll stick with those. I think I'm going to do 4 and 6, so I'm just going to measure the distance between them. We have about 3.1 centimeters, so I would convert that to meters. The voltage difference is 2 volts, so I do 2 volts divided by, that would be 0.031 meters, and then that would give me my electric field strength. Now we're going to do the point conductors, and for that I'm just going to remove this piece of paper and leave everything else in place because otherwise the setup is exactly the same. So I'm just going to unclip these from the copper tabs and then just peel up the tape and swap out for the other piece of paper. For this setup, rather than cutting long pieces of the conductive tape, we're going to do 2 shorter sections of 2 to 3 centimeters apiece. So again, I'm just going to grab the ruler, measure that out, and cut those. Now what I'm going to do with each of these strips is use the scissors and trim the ends so that I put like a semicircle on the end of each one. Then I'm going to fold both of these in half and then bend the rounded ends out to make a little tab. So the bottom of it, the 2 ends, are going to create like a circle, and then the rest of it will be the tab that we attach our alligator clip to. So when I finish, I should have something like this, where I've got the 2 rounded ends that form like a circle on the bottom, and then the rest of it is the tab. Now I need to place them on the paper, so I'm going to pull off the backing. And these ones are short enough that it should be okay to just peel it all the way off rather than just peeling it a little bit at a time like we did with the longer strips. Okay, so these ones are going to go at 7 and 10, so they'll be on the center line. And you want to orient the tab so that it's aligned with the direction of this center line. And I'll do the same thing with the other one. Again, I'll just remove the backing from the tape and stick the 2 halves together to form that center tab. Got to be careful when I do that so that the ends that are going to stick on the paper don't get stuck together too. Okay, so then I just place this. This one will be at 2110. There we go, just like that. This one didn't go on perfectly, but it's close enough, it'll work. From this point on, the setup and the procedure are pretty much identical to what we did with the parallel conductors. I just need to connect the positive battery wire to one of the conductors and the negative wire to the other conductor. And again, it doesn't matter which one you do. I'm going to do the same thing as I did before with the parallel conductors. I've already got it set up, so it doesn't make sense to switch things at this point. Then as before, the last part of our setup, we need to verify that we have connected everything properly. So I'm just going to use the positive probe and touch that to the negative conductor, and we have 0 volts as expected. Then I'm going to do this on the positive conductor, and this time we have 8.94 volts. So that's actually a lot lower than what we had before, and the reason for that, I filmed this actually on 2 days, and I forgot to disconnect the battery when I did this. So overnight it actually consumed some power by conducting current through the paper. So you might want to take that as a tip. When you get done with this experiment, disconnect your battery so that you aren't wasting it. because otherwise you're just going to be draining the battery and then not having it as much for the next experiments. Okay, let's see what it was again. 8.93 volts. All right, and then let's check the center between the two conductors, and we have 4.25, 4.28, somewhere around there, volts. So that seems about right. That's about halfway between the two, so we know that we have connected it properly. Next, we need to map out the equipotential lines, the same as we did before, using our red multimeter probe to find the voltages, and using the yellow China marker to mark the points for each one of those spots. So for this one, we're probably not going to be able to do the same voltages as before. We won't be able to do 1 volt, 2 volts, so on. I think we'll have to start at 2 volts. Let's just check. So right here we have 1.5. If I wanted to get 1, I would have to get pretty much right next to the conductor, which isn't really practical. So instead we'll start with 2 volts. Let me just find that now. I've got 2 volts right there. So I'm going to make a mark just like I did before by putting the China marker down, twisting it a little bit, and that leaves a mark. Now, as before, once we started making marks on the paper, we need to be very careful not to move the alligator clips because it will mess up the electric field. It will change it just slightly, so then some of the marks that we've put down previously will no longer be in the correct place. And this is going to be especially important for this setup because with the point conductors, we're going to have equipotential lines that form circles around the conductors. So that will mean that the points are going to want to cross underneath the alligator clips. Don't actually do that. Just come up close to it and then stop there. And then later when you remove the alligator clips, if you want to, you could approximate where the rest of the line would be and just trace that. So just make your lines up to and around the alligator clips, but don't try to go underneath them. Don't move them and put a spot underneath them. Don't do that because it will change the field. Just a reminder here, when you're measuring with the red multimeter probe, make sure that you're pointing straight down into the paper. If you're at an angle or something, the voltage sometimes changes a little bit, so just make sure that you're pointing straight down into the paper whenever you check the voltage there. Again, as I said, I'm going to stop. I'm not going to try to go underneath the alligator clip, so we'll just stop with what I have now and then just draw a line through each one of those points. So this is the 2 volt line, and now I'm going to go on to 3 volts, 4 volts, and so on until I can't get any closer to the other conductor. Now I've got all my points for the 3 volt line, so again I'm just going to draw a line through all of those points. And this one you can see is not a circle going around it, but kind of a stretched out circle or a distorted line. And eventually as we get closer to the center, they're going to be almost straight lines. Oh, whoops. Okay, well, I didn't mean to draw that big line, but that's the way it is. I can't take it off the paper now. One thing I want to mention real quick here, I said earlier that you don't have to be super accurate as far as where you're placing the points. If you can, I would suggest being accurate to plus or minus 0.01 volts. So right now I'm doing the 6 volt line. So let me just show you here. We'll find the next point, and I want to find it to within either 6.01 volts or at the lowest 5.99 volts. So right now there we go, 6.01, 6.02. Okay, let's try to get a little bit lower than that. 6.01, that's close enough. So I found that the variation of like plus or minus 0.01 volts seems to be about the size of the dot that the marker makes. So if you're within that range, then it's close enough because you're not going to be able to get super accurate. It's not like you're able to put a pinpoint down on the paper. You're putting a fairly large dot using this. So right now I've got lines up to 6 volts. I'm going to try to do the 7th volt, but you definitely won't be able to do 8 volts because that will be too close to the second conductor, just like the 1 volt was too close to the first conductor. So that's all of the equal potential lines that we can put on the paper for the point conductors. Now I just need to label them. So this was 2 volts, so I'll write plus 2 volts. This one was 3 volts. And 4 volts, 5 volts, and 6 volts. And the last one was 7 volts. Then as before, we need to draw the electric field lines, and those are going to originate on the positive conductor, end on the negative conductor, and they're going to be perpendicular to the equipotential lines. So that one went off the page. It might continue along and come back in perhaps over here. Again, that one continue off the page and maybe come back in over here. And I'm going to remove the alligator clips at this point, and let's just go ahead and complete those equipotential lines. These are approximations over here since I didn't actually measure it. Then I can also draw some electric field lines coming out straight, because those would come out straight going away in the opposite direction. Alright, now we need to add our arrows. So like I said before, electric field lines start on positive conductors and end on negative conductors. In my case, this was the positive conductor and this was the negative conductor. So let's first of all just do these lines here in the middle. So going from positive to negative, I can draw some arrows for those lines. Then for the other ones, you have to be just a little bit more careful and think about it, because these ones are kind of going in the opposite direction as those lines. But again, we want the arrows to come out of the positive conductors. So we want the arrow like that. This one, the arrow would be like that. And that one, the arrow is like that. Then these ones, the electric field lines come in to the negative conductor. So we want an arrow like that, and like that. The last thing to do is to approximate the electric field strength in between the two conductors. And we'll do that just like we did before, where we measure the distance between two equipotential lines, take the voltage difference between those two lines, and then divide by the distance. So I could probably use the 3 line, the 4, 5, or the 6 volt line. But I think I'm just going to use the 4 and the 5 in this case. So I'm just going to measure the distance between those two. And it looks like exactly 3 centimeters, so that would be 0.03 meters. So I would take 1 volt divided by 0.03 meters, and that would give me my electric field strength in volts per meter. Just a quick note before we finish. When you're done with the experiment, make sure to turn off your multimeter. These cheaper multimeters don't usually shut off automatically, so if you don't turn it off, it's just going to keep running and wearing down the battery. So just turn the dial to off so that saves the battery and it's ready to go for the next experiment. Also, if you didn't already disconnect the alligator clips from your conductive paper, make sure to disconnect the battery, because the battery is going to keep conducting current through that paper and it will wear it down, just like I said before. I left it on overnight and it decreased the battery, I think, by about 0.5 volts. So just whenever you get done, disconnect everything, make sure that you take it all down and you're not leaving things running after you finish the experiment.
And that's it. So just read your instructions. They will have more information than what is shared in the video. And good luck on your experiment.